Hello everyone, I hope you all are doing great. In this playlist, we will be designing serverless solutions with Azure Durable Functions. My name is Anshuman Dixit. I'm working as an Azure PaaS developer. So my stacks are belonging to Azure PaaS, React.js, .NET Core Web API, SQL Server. Mainly, I am working with Microsoft technologies mostly. Now, agenda of this entire playlist will be we will discuss what exactly a serverless architecture is, and we are facing some challenges in the serverless architecture. When it comes to durable Azure functions, what will be the overview for it? Then we will come for the advantages of durable Azure functions. Then I will show you a simple demo so that you will be understand everything related to durable Azure functions. Now, evolutions of applications. What exactly serverless solutions are? Serverless architecture, also known as serverless computing or functions as a service, is a software design pattern where applications are hosted by a third-party services, eliminating the need for software, server, and hardware maintainability by the developer. Applications are broken up into individual functionalities, so it definitely belong to single responsibility of the solid design pattern. So how the evolutions of applications came up? Before 10 years or before 15 years, people were doing everything in the on-premises network. Suppose you have a corporation or you have a company, so everything will be in your on-premises system, starting from the hardware to maintaining it, to develop, to deploy everything, to maintain the business logic. Everything has to be maintained by the developer as well as the administrator. Now things got changed. Now infrastructure as a service comes up. When that thing come up, uh, there are a couple of cloud provider came like Azure, uh, GCP, Google Cloud Platform, like AWS, Amazon Web Services, and other cloud platforms. So in infrastructure as a service, so what will be the responsibility of cloud provider is it will maintain the hardware, but from operating system to functionality, everything has to be maintained by the developer as well as the administrator of that corporation. Suppose you are having a Linux operating system or you are having a Windows operating system, you will be the responsible person to maintain the patches, to upgrade it, to maintain the entire applications. If applications is having a huge amount of traffic, you have to maintain it everything. Now it comes as container as a service. From now onwards, everything will be used as container as a service or platform as a service or function as a service. Now coming up to the container as a service, in Azure, we do have Azure Service Fabric and Azure Kubernetes. In Amazon also provides its own Kubernetes platform, and Google has its own Kubernetes platform. So what exactly these container as a services do? It takes the responsibility of hardware and the operating system from you. So you will not maintain anything in terms of hardware and operating system, but to develop the container, to deploy it, to maintain the containers, to scale out at the time of huge load, or to run it, to run the functionality or business logic, it all depends upon the developer and the administrator of the corporation. Now coming up to the platform as a service. Now cloud providers are giving us this flexibility that the hardware, the operating system, containers, runtime, or scalability or elasticity, everything has to be maintained by the cloud provider. You will be the responsible person to develop the application and to develop the business logic. So you will be only concentrating upon developing the business logic. Now then it comes as a function as a service, that is known as serverless platform. So what exactly serverless architecture is? It's not like serverless, just the naming convention it is coming it like this. But the thing is you will be getting build whenever you are running that applications. So from hardware to application, you will not be the responsible person to maintain it. It will be the responsibility of the cloud providers, just like Azure, Amazon Web Services, or GCP. Now coming up to the next slide. So what exactly the benefits of the serverless compute? The most beneficial thing is pay only for what you are using. Suppose you are using for 5 minutes and you are using for of 50% of CPU, then you will be getting paid for that. You will be getting billed for that thing only. So it doesn't depend upon what exactly are written in you have written in the code, in what time it is running. It's not depending upon that. Suppose it would have been a past services, it would have been run infinitely and you will be getting billed for that. But now it's only pay only for what you are using. Now the second thing comes up, like the abstractions of servers. Why the abstractions of servers? The applications are broken up into individual functionalities. Suppose in this entire slide, we will be discussing in the demo application that we will create a feedback generation system. Now, to send you mail after getting a feedback, it will not gonna be the responsibility of a single function. It will be the responsibility of different functionalities. So we will break that entire application into individual functionalities so that it can be scaled individually. Now the third thing comes up as load balancing or high availability built in. What exactly this means? Suppose Flipkart is having a big billion day sale, or any other company is having its own platform making, own cost making sales. That time the load will be getting high, the traffic will be getting high. So your system should manage those traffics. For that reason only we are using serverless platform, so that the load will be balanced and it will be highly available. But it will not be the responsibility of you, it will be the responsibility of the cloud vendors, whatever the cloud vendors you are using. Now, event driven scaling, not resource driven. What exactly this means? You will have multiple triggers. It will not be resource driven. Suppose I am having a timer triggered Azure Functions, then suppose I am trying to run some functionality in each Sunday 12 o'clock, then it will only get triggered at that time only. Now here the event will be that timer. Now suppose I am storing something in the SQL server, then I want to send an email to you that yes, something has been stored in the SQL server. Then here the trigger will be you are storing something in the SQL server or in the queue or in the messaging system. That will be the event for this thing. Now this is the small image I have taken from the Google. So what exactly this is showing is, this is the Azure function, and there will be trigger, there will be input, and there will be output. Remember one thing, to run an Azure functions you need at least one trigger. That can be blob storage, queue storage, service bus. Now suppose some file has been stored in a Azure blob storage. You want to pass something to the administrator that yes, this file has been stored. So it can trigger a Azure functions. Now some messaging queuing system you have developed, you are storing something in the service bus queue. Yeah, it will trigger the Azure function. So these are the triggers. So by this trigger only this Azure function will get triggered and run. Now to run this Azure functions, you might need some input parameters. Suppose I'm using sockets. Suppose I'm using a chat application. I have developed it by using sockets. So signal or services can be used as an input parameter. Or I am storing something in my Cosmos DB. So this will be an input. So I can take something from the Cosmos DB as an input, and then I will regenerate my process. I will generate my business logic. Then I will again store it in the output. So what exactly these outputs are? Some of them are third-party services. Some of them are provided by Azure services. Like SendGrid is the third-party service. but we can use blob storage, queue storage, or we can use signaler for socketing, or we can pass something to the service bus queue so that it can be invoked by other applications. Now, some challenges we are facing in the Azure Functions is Azure Function is stateless. Remember one thing, normal Azure Functions, what has been built by Azure, it is stateless. So for that, to overcome that challenge, we are using durable Azure Functions. Now, suppose in my feedback system, I will generate something, my flow will be, you will be giving feedback in a form. Now it will be stored inside a SQL Server. Now it will generate a ticket ID and it will send an email to you. Now suppose I have already divided this functionality into two Azure functions. Look this function chaining pattern. I have in first function I am storing it into the SQL Server. In second function I am sending you an email. Now this ticket ID has to come as an email. Now, where to store that ticket ID? I don't have any logic over here, right? So for that, I need to store it in a third-party services like Service Bus Queue or Blob Storage like that, because Azure Functions is inbuilt stateless. But in durable Azure Functions are stateful. We will be storing it in the same Azure Functions only. We will look into that. Now, parallel processing is very much important in scalability, in terms of scalability. Now, Azure Functions, in Azure, normal Azure Functions, it will be much more difficult, but in durable Azure Functions, it will be very much easier. Now, coming up to this part is a very interesting one. Uh, Azure Functions doesn't gives us flexibility to allow human interactions. Suppose I am a human, I want to interact something, and then again an Azure function will be triggered. Then it will analyze some sentiment from us. So for that thing, Azure function doesn't provide us that flexibility, but durable Azure functions gives us that flexibility. Now coming up to the next slide. Now we will discuss about durable Azure functions. What is the benefit of using durable Azure functions over the normal Azure functions? So this is normally this is Azure Functions extensions only. Suppose Azure Functions have some functionalities in its own term, and durable function is the superset of normal Azure Functions. It will be scalable, it will be stateful, it will be we can handle we can handle exceptions over there, and those things will come up in the durable Azure Functions. Based on the durable task framework, we will be using a NuGet package over there. So basically, we will change the normal Azure functions to a durable functions in that way. It implements stateful architectures. So why statefulness is very much important? Sometimes we really need to store our state. We don't need to store it in the service bus queue, and service bus queue again will be little bit costlier in terms of normal Azure functions. But in durable Azure functions, we can store it in in the functions only. Now it is supported by using popular languages like C Sharp, Node.js. Now Python is also got supported to write your entire code. We will be entirely using C Sharp language now, but you can actually go for the other languages once you develop something in the durable functions and you will deploy it to the Azure. Now advantages of using durable functions. We can process parallel executions over here. Suppose I have a functionality that I want to generate thousands or 500 PDFs at a time. So PDF generation is little bit time consuming. So that time we can go for the parallel execution, and it will parallelly execute every kind of PDFs. So it will create multiple instances of normal Azure functions, and it will generate the PDF. Now error handling is quite important. Now in normal Azure functions, we have already separated the entire applications into multiple chunks of Azure functions. Now what if something goes wrong in a suppose I have function 1, then I have function 2, then it is calling to function 3. We have functions chaining in that way. Suppose something goes wrong in the function 3, so function 1 will never going to understand that something has been wrong in the function 3, right? Because the error and exception handling also be done individually in the entire Azure Functions. But in durable Azure Functions, we can globally handle errors and exceptions. That is the main advantage of durable functions. Now, third point is tracks workflow progress, that is statefulness. Just I have told you, suppose I need that ticket ID once I generate it by storing it into the SQL Server. That ticket ID can be stored inside a Azure Functions. Now suppose I am using normal Azure Functions, I have to store it inside a service bus queue, or I have to store it inside a file, and it will be put to the blob storage. But now I can store it into the durable Azure Functions. Now waiting for the human interactions is very much important nowadays in terms of IoT. So this flexibility also given by durable functions. Now this is the durable functions components. Normally the architecture will be in this way. So what exactly the architecture is? There will be one orchestrator function and there will be one activity functions or more than one activity functions. And there will be one starter functions. Now the starter function has the responsibility to trigger the orchestrator function. That's it. Suppose I have triggers. Suppose I am using a timer triggered function. In each Sunday, I am doing this entire task in 12 o'clock. So the starter function will be get triggered by using that timer. That's it, nothing more. Now it is the responsibility of starter function to trigger the orchestrator functions. Now, what exactly orchestrator function will do? It will be the parent function of every kind of activity function. Now, it will store the state. It will handle the errors. It will do everything. It will call the activity functions in one by one, or any way you have written. In it depends upon the business requirement. Now activity function will have the normal responsibility. Suppose I am creating a feedback system. There are two, three responsibility. Suppose I want to store something in the SQL Server. It will be done by activity one function. Now I want to send you email. It will be done by activity two function. Now I want to create a support system so that that details will be sent to a service provider. Now you can contact with that service provider and you can get the status of that ticket ID. Those things will be done by activity 3 function. Now this is the design pattern in durable function apps we are using. In this entire demo we will be discussing about function chaining. Now how exactly the function chaining works. The orchestrator function will be the responsible function to invoke all the activity functions. Now, once the orchestrator function will call activity 1 will go and activity 1 will end its own task. Now, again, when the activity 1 ends up, it will again call the orchestrator function. Now, when the activity 1 is running, at that time, orchestrator function will be sleeping. It will not run, it will not give you cost. Now, once that activity function ends up, it will again call the orchestrator function. Now it has the responsibility of orchestrator function to call the activity function 2 by omitting the functionality of activity function 1. How exactly it will be done? Orchestrator function, if you have 100 if you have 10 lines of code in orchestrator function, for each line it maintains a cache memory into the queue storage. Orchestrator function will always going to be interacting with a queue storage. There it will be storing that cache memory that yes, this line of code has already been ran. So now this should not run and function 2 will be ran. Now then after that when function 2 ends up, it will again call the orchestrator function. Now orchestrator function wakes up. Now function 3 will be run. In this way, function chaining pattern goes on. Now coming up to the second one, this is known as fan out, fan in. Suppose I am trying to execute some parallel execution. Suppose I have to generate hundreds of PDFs. I really don't want to create one single Azure function and generate PDF in that way. Be- because Azure function is will be costly if you will not go for the timing. Suppose I have something like I'm actually running the Azure functions for 5 minutes for a single PDF. Suppose I have hundreds of PDF, it will run for 500 minutes. So it will not be possible in normal Azure functions because normal Azure function will give you maximum of 10 minutes to run. At that time, parallel execution is very important. Now that time durable Azure functions comes into picture. We can process the PDFs parallelly. We can generate parallel task, parallel Azure functions so that it will take the responsibility. Now again, after the functions gets over, it will again call the durable functions. It will again call the function 3. I hope you are understanding these things. Now coming up to the demo, whatever the thing I have shown you right now, I know that something will be understood and something will not be understood until and unless I show you the code. Now in the next video onwards, we will go for this demo. So this is a simple feedback system I have created. In this feedback system, what is happening? We will be having an UI. I have not created that UI. I will be using Postman. Postman is a API triggered tool. So I have different Azure functions over there. So by using Postman, I will create a feedback form. Now that feedback form will contain might be containing might be first name, last name, your email ID, and something you have written in the feedback. Now, once that feedback form will be triggered by using HTTP trigger, this is the starter function. This will be triggered by using HTTP API URL. Now, once that feedback form will be generated, it will call the starter function. Now, starter function will call the orchestrator function. It will not do any other things. It will only going to call orchestrator function. Now, once this orchestrator function goes up, sorry, just give me 1 minute. Yes. Now, if the orchestrator function goes up, now it will be the only responsible function to call all the activity functions. Now, the feedback form has some data. I want to store it into the SQL server. So it will call activity1 function. Now, when it will call the activity1 function, this orchestrator function will go to sleep. It will not cost you as it is not running. It is the main functionality of Azure Functions that whenever it will be running, it will have some cost and you will be getting billed for that. Now, as it is not running, you will not gonna be getting billed for those timing. Now it is the responsibility of activity 1 that it will save the feedback form data to a SQL DB. Suppose I am using Azure SQL over here, you can use MySQL, you can use Mongo, whatever you want to like. Now once the feedback form will be stored over there, it will generate a feedback ID and it will pass it to the orchestrator function. Now it is the responsibility of orchestrator function to store it in its own state so that that feedback ID will be sent to the second activity function which has that responsibility to send you an email. The email sending functionality is not be attached with the save feedback form functionality. It is independent upon this entire these all these other Azure functions. Now this feedback ID will be sent to the email functionality. Now email will be get triggered. You will be getting a ticket ID. Now, once you will be getting a ticket ID, it is the responsibility of the entire system to generate a support system, to generate a customer service provider, so that by using that ticket ID, you can contact to that person and you can go for the status of your ticket. So that will be done by the third Azure function. The third Azure functions, in this demo I have created a send a text file to the support team so that they will be able to understand what feedback you have given, and they will be assisting you by using that ticket ID, and you can contact these persons by using those tickets ID as well. So this will be the entire demo. From the next video onwards, we will definitely going to write some codes. We will create a starter function, we will create an orchestrator function, and we will create activity functions. And in that demo, we will store states in the orchestrator function, and we will use global error handling, and we will see how the orchestrator function is getting called again and again. Thank you for watching this video. Have a nice day. Please like, comment, and subscribe. Uh, we will see you in the next video. Thanks. Bye.